To see you all in this evening. Just I want to know what is the case study that we're going to discuss on today evening.
So today evening we are going to discuss the safety analysis of fireman's ladder.
Yeah, good to know that. Why I have chosen the fireman ladder for this case study? Is that yeah?
I am willing to.
Yeah, good. When we go for the firemen are climbing on a higher building, so they might face an issue. So you have taken that particular case study. Good to know that. Just to go with the free body diagram of how the ladder works. Later on, we go with the concept.
Yes.
You can use your pen to explain.
So this is a vertical wall. So the ladder is landing in the position. So we have the horizontal roof is landing. So we have the angle theta, and the normal force exerted on the vertical wall is NW, and the weight of the ladder is point to the center of the ladder.
Good.
Is we have take this small w. If the person is climbing on the ladder is, then his weight is acting downwards. That is we taken as capital W. If the ladder is sliding the left to right, so the friction is acted opposite in direction. So this direction is acting a friction force F, and the normal force is acting NF.
Yeah, good. Just this is the basic free body diagram of ladder. If I just imagine that if I am keeping a wall ladder to the wall at an angle of 80 degree, what will happen? 80 degree. Just imagine that 80 degree now. It will be
unable to climb.
Minimum inclination. Will be able to climb?
No sir.
No. Why?
Sir, 90 degree na.
There might be situation to fall down. Yeah, just you are able to understand the concept. Let's try to express in English. No issues. If I am keeping in the angle very minimum, what will happen?
So the ladder is sliding towards the roof.
Very minimum. Whether it will fall in the ground or it will be falling towards the
Fall in the ground.
fall in the ground. It will be very minimum. When we start climbing, immediately it will fall to the ground. Yeah, just go with the real world examples.
Sir, used by firefighters, electricians, and construction workers.
Yeah, good. Then
So load chart, understanding critical angles and loading limit helps prevent accidents.
then
So then OSHA and the NFPA recommended keeping angles between 70 to 75 degree for stability.
good. Then what are the conditions?
So sum of horizontal force is 0, sum of vertical force is 0, sum of moment of about any point is equal to 0.
So this is the condition to maintain in an equilibrium condition. Just go with the real case that you have taken. What is the problem statement?
So we have the problem statement that the one ladder is standing on the vertical wall. So we have the uniform ladder of length L, capital L, and the weight the capital W rest against the vertical wall. The fireman of weight small w climbs a distance d along the ladder. So the fireman climbs the distance along d along the ladder. So the ladder makes an angle theta. We have already seen in the free body diagram. Here the theta, and the wall and the floor may offer friction. We have seen the friction force is opposite to the ladder sliding.
Good. What is the main objective?
So goal to analyze the static stability of ladder and to apply friction law to prevent slippage, understand condition for safe use by firemen.
Yeah, just I want to know what are the safety concepts that you have developed.
So maintain angle between 70 to 75 degree. Use rubber feet and wall grips. Don't clip too high. Stay within stable region. Ensure high friction surface.
So these are the safety concepts that you have taken over here. Just go with the final answers that you want to conclude.
So we have the case, for example, where L is equal to 5 meter, W is equal to 200 Newton, and we have the small w, weight of the person is equal to 600 Newton, and we have the refractive index, that the
Coefficient of friction, yeah.
So 0.4, and theta is equal to 70 degree.
So if the particular person climbs in this inclination, there might not be any chance to fall down. So this was the real case that you have observed. Good to know.
Give a conclusion words.
Yes, go ahead.
Friction plus torque balance determines ladder safety. Mathematical models help set safety limits. Important in real world firefighters safety industrial protocols.
Just imagine if you are having a floor like this smooth floor, If you place an inclined wall over here at an angle of 75 degrees, will you able to withstand?
No, sir.
No. Yeah, just this is the one I want to know from you. Ladder over here. If you are placing a ladder here, will you be able to maintain the 70 degree inclination, the smooth flow?
No, sir.
Why?
So we don't have a friction, smooth flow.
Yeah, in the smooth flow we are not having friction, so that we are not able to climb with this inclination. What we should do when we are placing a ladder over here, either we should give any support at the end, or just like that we can increase the angle. Increase the angle itself, not sufficient. We have to give a support at the base so that it will not slip down. Thank you.